All right. Finishing 10.2. Finish 10.2. Have you ever seen a acorn floating by in a boat? Whoa, I don't know, but there it goes. Woo! Oh, look, here it comes again. Whoa, acorn boat. Woo! Thanks for watching. Okay, here we go. So where we left off last time was, there we go. So where we left last time was, oh yeah. So we were trying to find all angles in radians given that sine equals some ratio. Find the angle. We're like reversing trig functions, right? Reversing trig functions. Okay, so that's a good one. Looks like you're going to have to solve these trig functions without using the calculator, find all the solutions between 0 and 2 pi, isolate the trig function, and then draw triangles. So here's your key, is to isolate the trig functions. That's your key, and then draw your triangles. So solve for tangent, isolate it, solve for it. So what we're going to do is we're going to add 1 to the other side. So we get tangent squared of x is equal to, add 1 to the other side, so 1. Then we're going to go ahead and square root both sides, right? We're going to square root both sides. Boom, boom. Well, what happens when you square roots? Do you remember? Plus or minus, plus or minus. So we're actually going to get two equations here. We have a tangent of x is equal to plus or minus. So we have a positive one, and tangent of x is equal to a negative one. Right? So now that we solved it, we can go ahead and graph it. And we're going to be doing all the coordinates because we have plus or minus. So we're going to be doing all the coordinates, y and x, all the coordinates. So what is tangent again? So tangent is opposite over hypotenuse. And so we also have over here opposite over hypotenuse. So I want you to think about it. If you have a triangle with opposite one and adjacent one, no, hypotenuse, wait, that's supposed to be adjacent. Sorry about that. Yeah, did you notice that? Extra credit. So that's going to be 1 over 1, so opposite over adjacent. There we go. So if you have opposite over adjacent, any whole number can be written over the number 1. So opposite over adjacent. Cool. So if you have a right triangle, think about it now. If you have a right triangle with the sides that are the same, 1 over 1, that means the hypotenuse is probably a special right triangle. Do you know what it is? Say it into the screen so I can hear you. Say it. Radical 2. It's a 1, 1 radical 2 with 45-degree angles. Okay. So let's see. Where's tangent positive, first of all? So tangent is positive on here and down here. So we're going to draw those 45-degree angles now. Draw those angles. Not exactly quite to spec there, but nearly. And so positive, let's see. So it's going to be over 1 and up 1. And then technically this is negative 1, down 1. Well, how's that positive? The reason why is because negative divided by negative is a positive 1. So that still works. Okay, and then this has to be, use Pythagorean theorem, we get radical 2 for the hypotenuse. And that means this is a 45, 45, 90, special right triangle. Now they want it in radians. They want it in radians. Let's see here. So that's going to be the angles we find. One of our answers is pi over 4. It's 45 degrees. Now you're going to the hypotenuse, okay? If you're going to the hypotenuse, the terminal side is where your angle is as one of your solutions. And then this one is going all the way around to here, so that's 1 pi over 4, 2 pi over 4, 3 pi over 4, 3 pi over 4, and then down here would be 4 pi over 4, and then finally, that's pi, and then finally down here is 5 pi over 4. So we also go all the way around to this angle right there. So this angle right here is 5 pi over 4. So those are our two solutions for 17 for positive 1. Now we still have to do negative 1. Oh, what? So where is tangent equal to negative 1? So tangent is equal to negative here and here. So we're going to draw these as well, draw these as well. Draw the reference triangle. Draw the reference triangle, there it is. And again, it's going to still be 1 because opposite is negative 1, so yeah, it's down here. And adjacent is positive 1. And over here, this will be positive 1, and this here will be negative 1. Cool. So still 45, 45, 90, right triangles. And now we just need to find them in radians. So now we're going to go in orange. We're going to go all the way around to that terminal, that hypotenuse, boom. So that's 1 pi over 4, 2 pi over 4, and yep, 3 pi over 4. This is one of our answers. One of our answers. Okay, last one, keep going. So 4 pi over 4, 5 pi over 4, 6 pi over 4, and finally, boom, 7 pi over 4. So we have 4 answers there. Let me get my answer key and double check. Okay, looking good, looking good. Yep, those are our 4 answers. So 4 answers now for X are, that's this video. Nice. Okay, so our 4 answers for X, actually theta as we would like to call it, but whatever. So that's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. 4 answers. Check all the answers. Check all the answers. Okay, so now we're going to number 19 next. So let's see here. Not too bad. Cool. Okay, so again, you want to isolate the trig function. Get it by itself. Isolate it before you draw your triangles. So we're going to add 2 to the other side. If it lets us. So we're going to add 2 to the other side. Nice. And while we're doing that, we're going to divide also by radical 3. No, show your work, people. Don't confuse them. Okay, step at a time. So that's cosecant x is equal to 2 because we added 2 to the other side. Then that's being multiplied. It's being multiplied, so we're going to divide now. So we're going to divide by radical 3. Okay, now we isolated it. Now we isolated it. Good. What is cosecant of x? So cosecant of x, what is it? Cosecant of x is 1 over sine. So that's the opposite of sine. So it's going to be hypotenuse over opposite. And so cosecant of x is equal to 2 over radical 3, where hypotenuse is 2, and radical 3 is the opposite. Cool. Okay, so where is sine? We have to assume, because there is no negative, so we have to assume it's positive. So where is sine positive? So sine is positive in the first and second quadrant. All students take calculus. Remember, all students take calculus. Okay, so it's positive in the first and second quadrant. And our opposite is going to be radical 3. So that means our opposite is going to be really big. Our opposite side to our reference triangle is going to be big. There it is. It's going to be radical 3. And the hypotenuse is 2. Right, hypotenuse is 2. Opposite side of our angle that we're trying to find is radical 3. And then we also have this side too. So we're going to go up there. So that's also radical 3. And this is also hypotenuse 2. And if you use the Pythagorean theorem, Pythagorean theorem. So Pythagorean theorem, if you had the Pythagorean theorem, you would be able to solve for this side. And so that side would be just a 1, right? The short leg, just be a 1. Let's try it. So we have like a squared plus radical 3 squared equals 2 squared. That's 4. Those cancel. That's 3. And yep, you're going to minus 3 over. So we get a squared is equal to 1. And then we square both sides. So equals 1. So our adjacent side is 1, and this side is negative 1. Okay, so what
what angle goes with a 1 radical 3, 2 right triangle? 30, 60, 90, right? But which one's the long leg with the radical 3, opposite the long leg? Which degree is opposite radical 3? Remember? Say it. Say it. It's 60 degrees, right? 60 degrees. 60 degrees. So now to find our two answers, we're going to start at 0. We're going to go all the way to the hypotenuse. That's the hypotenuse. Terminal side is your answer. And so 60 degrees, what is that in radians? So 60 degrees, you can times by pi, divide by 180. And so you divide by 60, divide by 60. When you divide by 60, you get pi over 6. Wait a second. 60 degrees. No, you don't. You get pi over 3. You will. You do. You get pi over 3. So pi over 3 is one of our answers. Good. And then let's see here. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6. This is 30 degrees. So that's going to be 4 pi over 6. And so 4 pi over 6, what does that reduce to? That's our other angle we're looking for. And so that reduces to what? 2 pi over 3? 2 pi over 3. So our two answers for x are 2 pi over 3 and also pi over 3. Put them in order, new bold. So it's going to be pi over 3 and 2 pi over 3. Way-o. So those are our two answers there for number 19. So try 16 on your own, try 18 on your own, try 20 on your own, try 21 on your own. You got this. You got this. Right? Try 21 on your own. Let me see where we're at. Oh man, I have to get home. My wife's going to kill me. Ooh, it's already ready to go. You just have to square root both sides. And if you square root both sides, you get sine of x equals plus or minus the square root of 1/2, which is the same as square root of 1 over radical 2. And so that means the sine of x equals a positive 1 over radical 2. And also, a equals a negative 1 over radical 2. Right? So you have to do 2 of them on this one. Okay, now I want you to pause me. You try the rest of 21 on your own. Pause me. I'm waiting. I'm waiting. You pause me now. Pause me. I'm waiting. Pause me. I am waiting. Try 21 on your own and then check your answers up here. Try it. You got this. Okay, let's see here. Did you pause me? Did you try it? Okay, so sine is opposite over hypotenuse. So that's going to be the small little 1 there over the hypotenuse radical 2. Wait a sec. This is going to be a 45, 45, 90 where the legs are the same. 1, 1, radical 2. So that means that we can draw it right in the middle. These are going to be 45-degree angles. Where is sine positive? So sine is positive here and here. And so it's going to be opposite 1 over radical 2. And if you use the Pythagorean theorem, this side will also be 1. Right? And then we'll also have this is opposites over hypotenuse, which opposite is also 1. Hypotenuse is radical 2. And this will also be 1 using the Pythagorean theorem. That'll also be 1. Try it. And so this is going to be a 45-degree angle now. 45-degree angle. And then this will also be also negative, which is below. Below as well. Whoa, there's our butterfly. There's our bow tie. Right? Butterfly, bow tie. Okay, so now we just need to find those 4 terminal angles. Right? 4 terminal angles. So the first one is 45 degrees, or pi over 4. That's our first one. Our next one goes all the way to here. So that's 1 pi over 4, 2 pi over 4. So our next one is 3 pi over 4. Cool. So then after that, we're going to go all the way over here. So that's 4 pi over 4. The next one is 5 pi over 4 is another answer. And then our last one, which should we use magenta? You know we should use pink.
Okay, we're going to go all the way around now. All the way around to that one. So that's 6 pi over 4 next. And then that's it, 7 pi over 4. So those are our 4 answers for problem number 21. Those are our 4 answers. Nice. Is that what you got? Did you try this on your own? Did you get all 4 answers? Did you get all 4 answers? So we got 1 pi over 4, we got 3 pi over 4, 5 pi over 4, and 7 pi over 4. Thanks so much for trying to work hard and learn this with me, right? Okay, so you try the evens. Let's do an odd here. Use your graphic calculator to find the solution of each equation between 0 and pi. Okay, cool. We can do that. So get out your calculator now. Get out your grapher. Hit y equals. We're going to type in the left side first. So 4 sine x, right? And then down below, we're going to do the next one on the right side. So basically, this is y1 and this is y2. We're just going to use the intersection feature. So that's cosine of x plus 2. Highly recommend you use second trace and that you use trig. So second calc, and then use intersection, right? Intersection. Wait, that's really zoomed in. Sorry. Go to Zoom. Go to Zoom. Go to Zoom. So next we go to Zoom. And probably the best way to do that is probably zoom trig. So let's go and do 7 zoom trig. So we're going to hit zoom and then so 7 z trig. It's probably the best window to help us. Best window. Z trig. So zoom trig. There we go. There it is. Beautiful. So we're going between 0 and 2 pi. We're going between 0 and 2 pi there. Okay? And so we push trace, and there's 0. And so we're going all the way to 2 pi. So 2 pi goes all the way there. Yeah, 360 degrees or 2 pi. So we're going to ignore that one. All we're going to focus on is these first two intersections. The other one is too far. The other one's too far. Okay, so we go back here, and we're now going to do our intersection, right? We're hitting trace there to do that. So we're going to hit trace. And then you're going to go ahead and hit second calc. And you're going to do the intersect. Intersect feature, which is option 5. The intersect feature, which is option 5. So you're going to go with second calc. Intersect feature, which is option 5. Then it says first curve. So then it says first curve. So then we hit enter. And then first curve enter, second curve, enter, and then guess. Yep, just hit enter. Hit enter. Okay, so enter, enter, enter. Make sure you're over the intersection, by the way. Make sure you're over the intersection. Well, we need to be in radians. We need to be in radians? We need to be in radians. Uh-oh. Uh-oh. Be in radians. That means we need to go to the radian mode. So we go back to our calculator. We go to mode. We go to radians. Go to radians. And then we hit graph again. Oh my goodness, that's crazy. What just happened? My heart just went that fast. Ah, heartbeat. We're going to have to go to window. So hit the window button. We're going to have to go from 0 to 2 pi. Okay? Because that's what we want to do. We're going to go from 0 to 2 pi. So that was under window. So 0 to 2 pi. Okay, now we hit graph. Hit graph next. So there's our two intersections. So here's our first intersection. Ooh, we can switch back and forth. You need to trace over. Trace over to the intersection. So trace over to the intersection. Now you're going to go ahead and go for it. So you're going to go second, trace, second calc. Go down to intersection. Push enter. And then enter, enter, enter. Okay, our intersection is 0.75142333. Wow. That does not help at all, does it? Does not help at all, but I guess we'll use it. Okay, so then it's going to be 0.75. Okay, so we get our answers now. We get our answers. So the intersection for these two is going to be x equals 0.75. Is going to say, not the nearest hundredth, I guess. So that's 2 decimals. 2 decimals. Nearest hundredth. Okay, beautiful. Okay, so there's our intersection, 0.75. Then we'll hit trace again, and we'll head over to the other one. Oh, too far. I'm back. Okay, so do it again. Second calc. You're going to go to intersection. Enter, enter, enter. And enter. Okay, 2.8. 2.88. So the other answer is that x equals 2.88. And so those are your two answers for question 23. Those are two answers there for question 23. Good job. So now you try for number 22. You try that same process. And also number 24. You try. You try now. Try doing the intersection, trace over, then second trace, intersect, option 5, intersect, option 5, intersect, right, intersect, and then enter, enter, enter. Enter times 3. Enter, enter, enter. Cool. Okay, you got this. You got this. Last one, last one. Okay, in a right triangle, one of the acute angles measures is inverse tangent of A over B. What is cosecant of tangent of inverse of A over B? Wow. Let's find this first. And so we have tangent of -1 of A over B. And so if we go ahead, and that's going to be an opposite over adjacent. So inverse tangent of A over B. So in a right triangle, what are the acute angle measures? What are the acute angle measures? Let's draw our right triangle. Okay, so one of our acute angle measures, we'll say this guy, is inverse tangent of A over B. So that'll be A, which is opposite, and B, which will be, wow, it's wrong. Ooh, a little better. Okay, so that's A over B because it's opposite over adjacent. And because opposite over adjacent is tangent. Because tangent is opposite over adjacent. Cool. Okay, okay, okay. We got it, we got it, we got it. Okay, so now that we have that, so what is the angle? Whatever that angle is, it's right there. There it is. Whatever that angle is, it's right there. Okay, so then C will be the hypotenuse. And so now we want to do cosecant of that. Well, cosecant is 1 over sine. And 1 over sine is hypotenuse over opposite. There we go. And so that is not C. That's going to be a thing. Let's see what this is. What is this actually? We'll call it C. We'll do A squared plus B squared is equal to C squared. And then we'll square root both sides. So C is actually the square root of A squared plus B squared. Okay, so now we're going to know what hypotenuse over opposite is. So that's hypotenuse over opposite. So the square root of A squared plus B squared over A. I'm guessing it's E. Is it E? Is it E? All right, you behind the screen, thanks for watching. Don't forget to float your pine cone every day, right? Float it every day. Woo! Yeah. Thanks for watching. You behind the screen, thanks for watching. Bye for now. Woo! Bam.